All right. So, hello everyone. Hello and welcome everyone to this amazing platform of TUT Learning. Welcome back to these amazing sessions of continuity and differentiability. Right. So today we are going to have the part 2 of limits, continuity, differentiability, which I have started up in the previous class. Right. So, hello everyone. Right. So, welcome all of you to this amazing platform. Okay. So, if you're new to this particular platform, I would say please consider subscribing and hit the bell icon because we are coming live each and every day and we are basically discussing all the important chapters of maths, especially for the upcoming JEE mains and advanced examination. So, if you're someone currently in class 11th and class 12 and you're preparing for the JEE mains and JEE advanced examination, you are at the right platform from where you can get quality educations just for free. Okay, so if you want to get started on this particular platform, please hit the subscribe button and help us. And also I would request all of you to please share these videos among your friends so that they can also take the best benefit of this particular platform. Okay, so the best part is that we are coming live each and every day and we are discussing each and every topic of mathematics, and especially we are helping you out for preparing for the upcoming JEE Mains examination. Right. So with this part, let's get started. And today is the part 2 of this particular session of limits, continuity, and differentiability. So if you haven't watched the part 1, I would request all of you to please go through the previous video and please watch the part 1. Okay. In the live tab of this particular channel, you can find up all the videos that have taken so far. Okay. So please make sure that you watch that particular video before coming on to joining this video over here. Okay. So with this, so this is basically part 2. Sorry, this should be part 2. This should be part 2, right? Great. This is part 2 of our studies of for limits, continuity and differentiability. Okay, and this particular content is especially for the JEE 2026, right? So anyone who is preparing for JEE 2026, for someone who is currently in class 12 and someone who is also preparing for JEE 2027, this video lectures is going to be really helpful for all of you. Okay, especially for class 11th and class 12, this is going to be really useful. And someone who is also trying to build their basics parts in algebra or like in calculus part, okay, and you have already covered these functions, sets, relations, all things, and you are basically practicing for some such exam where calculus is basically asked. These videos are going to help you a lot in order to study those portions. Okay, so let's get started on this particular session, and in this session we are going to discuss the concepts, and with the concepts we are also going to solve some of the questions as well. Okay, which is something that you will definitely like. Okay, so because I personally feel that when you practice questions with concepts, once you understand the concept, you practice a question, concepts and question, that is the best way to get the entire learning. Okay, so please try to follow the concepts and also try to solve the questions from your end as well. Okay, you're not only just copying the questions as I'm going on solving. Okay, so please make sure that you do that because that is really going to help you out in preparing for your upcoming examinations. Okay, so if you meet up all those basic requirement, I think these videos are going to be gold mine for all of you. Okay, so with this, let's get started. Now before I start, there is a very good news for all of our students. Basically I am basically starting a monthly live classes, or it's kind of an online batches where you can enroll yourself by just at a minimum fees of 999. Okay, this batch is going to start up very soon and the prices of these batches is just at 999 only. Okay, so you can get access to these live batches, and the best part of this live batches is that you can also get access to the one-on-one online tuition. Okay, so the best part is basically one-on-one. Okay, so we can sit one-on-one in a Google Meet. Okay, and we basically have the classes, so where you can ask your personalized doubt, where I can share your personalized material. So it is better than the other form of coaching as well, because in general form of online coaching where there are basically like 10,000 or sorry, 10,000 is a too large number, but yeah, sometimes like 1,000 2,000 students are basically attending the class at the same time, right? So in that case it is pretty much likely that your questions are not going to be picked up by the teacher. Okay, and in that case you're definitely going to have doubts in your concepts, right? So in order to avoid doing that, and you want to get your personalized doubt clearance and all this personalized effort, as well as you want to get your concepts cleared and you want to work out and you want to know that where you are actually lagging behind. So for all those personalized attention and monthly tuition, you can definitely enroll with us. Okay, so please contact on this number. The number is given on the screen. It is 9833 9827528. Please contact us on this number to get connected with me. Okay, please contact on this particular number and get connected with me. And also you can join us with our online batches to know more about the schedule and how we proceed with these batches and how what will be the timetable of these batches. Please contact on this number. Okay, you can drop a WhatsApp message, or you can also contact directly on this particular number to get personalized online tuition as well. Right, so with this part, let's get started. So before I start, I want to discuss about the different types of continuity that you have studied so far, right? So if we talk about continuity, we generally mean continuity as continuity of any graph will be defined as it is the ability to draw the graph of the particular mathematical function without having the effort to lift your pencil, right? So it is the simplest definition that I can explain to all of you, right? So if I say that I am drawing a continuous graph, so what do I basically mean by drawing a continuous graph is that for when I'm doing a continuity or when I'm doing a continuous graph of function, the best way to describe the continuity of function is basically when you draw the graph of the function without even having the effort to lift up your pen and then drawing it. So you are just drawing it continuously, right? It's like a continuous smooth curve, right? So that is the ability. That ability is basically defined as the continuity. Okay, so it is basically the ability to draw a graph without having to lift the pencil, right? To understand it better, I have taken a simple example. As you can see, okay, the example shows multiple data points on the x-axis and the equation on the curve over here, right? So let us try to investigate at each of the following points that I have taken up, and I have taken up certain points like x equals to -3, x equals to 0. I have taken up x equals to +2. I have taken up point x equals to 4. Okay, I have taken up x equals to 5. I have taken up point x equals to 6. Okay, so we are going to investigate about functions about these particular data points, right? So let us try to analyze this particular parts over here. So then if we start doing that, let us first of all see that when I'm drawing the curve of this function over here, so it is basically kind of like I'm not having to lift my pen, right? Now suddenly at x equals to -3, this particular function is not defined. So there is an open bubble over here. There is an open bubble, right? So I hope you can see that there is a simple open bubble which basically denotes that the function is not defined at that particular point. So I would say this particular function is not defined at x equals to 3. Okay, so just let me erase it. Yeah, so it is basically not defined at x equals to 3, because you can see that value of function at x equal to -3, it is basically not defined on this graphical lines, right? So I cannot say that void is the value. So this kind of definition of discontinuity, because it's obviously a discontinuity, we have to have a break in the in drawing the graph of the function. So at x equals to -3, it is a discontinuous function and the value is actually not defined at x equals to -3. Hence, wherever this value is not defined, such discontinuity is basically called as removable discontinuity, because you can always remove this discontinuity by defining the functional value at x equals to -3 exactly to the value that the function would take if it was a continuous function. So I can see that this is basically corresponding to 2. So if I define f of -3 as equal to 2, then it would the discontinuity would have been removed, right? So in this case, I will be able to define the continuity nature of the function, right? So therefore, this kind of discontinuity, we generally call it as non-removable discontinuity, right? Now let us come back to the point x equals to 0. So if you look at x equals to 0, the function is not defined with this curve. The function is not defined with this curve. So there is an open bubble over here. But at x equals to 0, it takes a closed bubble at y equal to 3. So what I can say, the functional value at x equals to 0 is basically 3. Whereas if you investigate the value of the function exactly at some point which is smaller than 0, that is 0 negative, so that value you can find it up almost equal to 0. And similarly, for 0 positive, you can find this value is almost closer to 3. So what you can see, that there is a jump in the value as you are transiting from x equals to via x equal to 0, right? So when you are going from x equals to 0, when you are going y x equals to 0, when you are transiting from 0 negative to 0 positive, or some value which is lesser than 0 to some value which is greater than 0. So you can see that the value is changing by a drastic amount. So there is a jump. Okay, there is a jump. So this kind of discontinuity, we called it as jump discontinuity, right? So this kind of discontinuity is defined as jump discontinuity. Okay, so you can understand that the limit on the left hand is not equal to the limit on the right hand. Simple thing. Now let us come to x equals to 2. So if you look at x equals to 2, again it's the same thing. At x equals to 2, the value is equals to, so at x equals to 2, the value is equals to minus of 1, whereas at the values of x equal to negative, means the values which is less than x equals to 2, that particular thing is almost equal to 1, and at values of x 2 plus, which is little bit greater than 2, so at those values you are going to have the function of value that is equal to 1. So what you can see, the left hand limit and the right hand limit are equal. That means the limit exists, but the limiting value is not equal to the value of the function, right? It is not equal to the value of the function. Hence in this case the discontinuity is a removable discontinuity, because we can again redefine the value of the function such that it is equal to the value of the limit. So this kind of discontinuity is also called as removable discontinuity, right? Now let us come back to x equals to 4. So if we look at x equals to 4 over here, we can see that the value of the function and the value of the function before 4 and after 4 is the same. So this particular function will be continuous at x equal to 4. Similarly, at x equals to 5, also you can see that the functional value and the limiting value are almost equal to 3. Right. So therefore, in this case also the function is going to be continuous, right? Because you don't have to make that effort of lifting your pencil, right? But interestingly, now, I don't know how many of you know this particular fact or not, but for example, if I have limit such that extending to some quantity, let us say a, for a function, and it is equals to some infinity, right? So in this case, we generally don't say that the limit is existing, because infinity is not a finite number. Okay, so limiting value, for a limiting value to exist, and it should be a finite quantity. Okay, it cannot be infinite. Okay, so in infinity, limit equals to infinity is not the correct way to say. In that case, if limiting value is going to infinity, then we should say that it is not, the limit does not exist, or I should say the limit does not exist, but sometimes it is in layman term we call it infinity, right? But very important to understand, the limiting value should be a finite quantity, right? The limiting value should be a finite quantity. That is very, very important. And for limit to exist, your LHL, I mean the left hand limit, should be equal to the right hand limit. Very, very important, right? So if you look at x equals to 6, if you just look into the graph over here at x equals to 6 over here, so what you find out that at the value of x equals to 6, the function is neither defined, and if you look at some values of 6 positive, like if you look at some values of 6 positive, it is going to minus infinity. I should not write equal to, because infinity is not a number. I should write it as it tends to minus infinity, and at values of 6 negative, it again tends to minus infinity, right? So what you can see is that in both the cases, before and after 6, it is tending towards negative infinity. So in this case, the value of the limit is equals to negative infinity. I should not say equals to, I should say tends to. Okay, because again, any value cannot be equal to infinity, because infinity is not a number, it's a concept. So it is tending towards negative infinity, and therefore and also it is not defined at exactly at equal to 6. So in this discontinuity, we call it as infinite discontinuity. Okay, so this kind of discontinuity is called as infinite discontinuity. I hope this particular discussion about the types of discontinuity, what I discussed, is clear to all of you. Please let me know if this part is clear or not. Please do let me know if this part is clear or not, then we can proceed with the next topic. Okay, so it's very, very important to have this particular idea before we start on to solve some real questions. Okay, I have taken up some different types of questions, so don't worry, we're going to have a lot of fun in discussing the questions. Okay, so please let me know if you are good to go with this particular concept over here. Okay, it's a simple idea. For continuity of a function, the simple thing that you need to check is first of all, you need to check the limit. Okay, so let's say I'm interested to find the continuity at x equals to a. So I will find the limit extending towards a for that particular function, and if it is equals to function of value of f of a, then I would say the particular function is continuous. Okay, So this is the only the condition that you need to check for continuity. Okay, got it? Is this part clear to all of you? Right? I hope this particular part is making sense for all of you, right? And we can proceed to the next topic. Okay, so next we have with us another very important theorem, which is also it is a very obvious thing of continuity functions, but it is very important because sometimes you will have the to prove questions. Okay, so sometimes you have to prove this condition, or sometimes there will be certain inequalities that comes up in the questions. Okay, there will be 4 different inequalities given as options. Okay, sometimes for JEE Advanced especially I've seen this a lot. Okay, there in one of the part of the option, intermediate value theorem has to be applied. Okay, so it is very useful to have this idea before we start on to solve real questions. Okay, sometimes in JEE Mains also you can find out many questions on this particular topic as well. Okay, so let's try to understand what is this thing called as intermediate value theorem. In short, we also call this as IVT. Okay, intermediate value theorem. Okay, so let us say I have a function f of x and it is continuous on this closed domain a to b, and let's say m be the number between, and let's say m be any number between f of a and f of b, then there exists a number c such that your c is lying between a and b, and I will have f of c to be equal to m. Okay, where m is basically any number that basically lies in between f of b to f of a, right? So intermediate values theorem says that if we have a continuous function, I have also drawn a figure to explain you the thing is that, so let's say I have a continuous function. As you can see, this curve of this function is continuous, and let us say it is defined within x equals to a to x equals to b, let's say over here, right? And our m is basically defined in between f of b to from f of a to f of b, right? So it will be very much possible, or I would say at least I would get at least, okay, there exists a number, at least one, okay, I should say at least one c, okay, at least one c for which I will have f of c to be equal to the value m. Okay, now this is very very important because sometimes the questions will come up, find the roots of that particular solution. So sometimes like the equation will be given like f of c minus m is equal to 0, find the roots for it. Okay, so we can say that there will be at least one roots, okay, in this kind of questions. Okay, so that is very very obvious. Okay, and as you can see that sometimes it might be there that this value is function equal to m, because if it has to be continuous, it can either go increase, it can decrease, increase, decrease, anything it can happen. But yeah, definitely at least for one c you will definitely get a value which is equals to m, right? So that is something that you need to keep in mind before we start to solve on the real questions. Okay, so let us try to solve some real question right now. Okay, are we all ready to solve some questions? Please let me know if you still have any confusion. Okay, great. So let us try to start with solving some questions. Okay, so here we go with the first question of today, and this is really really easy question. So if you recall the last class, what I mentioned is that now something that you also need to know while you start to solve is that I have already mentioned that sometimes expansions or the questions of expansions are very, if you use expansion, sometimes the questions of limit is very very easy. Okay, so if you look at this function over here, it is said that the function over here f of x, which is given as tan of tan x minus sine of sin x divided by tan x minus sin x, and it is said that this particular function is continuous. Okay, this particular function is continuous at x equals to 0. This particular function is continuous at x equals to 0. Now, if it is continuous at x equal to 0, you have to find out what is the value of f of 0. So, we know from continuity is that the function value at that particular point where we are talking about the continuity, it should be equals to the limit x tending towards 0 for the function f of x. Okay, now this should holds true. So what we need to do, we simply need to calculate the limit of this particular function at x tending towards 0. Okay, so that is limit of tan x minus sine of sin x whole divided upon tan x minus sin x, right? So now what I'm going to do is going to do some kind of simplification over here. So first thing first, what I can do is that I can try to change these parts, or I can write this same expression into a different form, so that now I don't think you will have any difficulty. Is that I am going to write this in a different way. Okay, maybe you can solve it by doing tan of x by x is tending towards 1 by limiting instant to 0, right? Something like that you can also do it, but what I'm going to do is I'm going to do some kind of different technique that will like very odd to you, but yeah, but sometimes the answers comes very easily by this also. Okay, so what I'm doing, I'm trying to express this in terms of a different relation, such that I'm going to get the limit very easily. Okay, so what I'm doing, I'm writing tan of tan x minus tan x divided by tan cube x. So in this case, if you apply this limit, this is basically, and then in this case you have to just multiply with tan cube x upon x cube, right? So and then plus tan x minus sin x divided by x cube, and then plus sin x minus sin of sin x divided by sin cube x, and then multiplied with sin cube x by x cube, right? So what I'm doing is, and then whole divided by tan x minus sin x and divided by x cube. So why I'm doing it is basically that you will be amazed to know that this particular thing will go towards 1 and this particular thing will go towards 1 upon third just by expansions. Similarly, this particular thing will go towards half. Okay, tan x minus sin x by x cube is basically towards half. You can also prove this by putting some expansions. Okay, similarly over here, this particular part will tend toward 1 upon 6. So therefore your limiting value, or the value of the function at x equals to 0, which is the limiting value, it will become up as half plus 1 upon 6 plus 1 third plus 1 by 2. Okay, plus 1 by 2, and then we'll have 1 by 6. Okay, is this part clear to all of you? Okay, and then divided by again one more half. So if you evaluate this is going to give you the value of the function at x equals to 0. So the function value at x equals to 0, this should come out as, are you all getting the answer as 2? Please let me know what is the answer are you getting. So the answer to this question, this is an integer type question, and the answer to this question is basically going to be equal to 2. Please let me know what is the solution, what is the answer, what is the answer you're getting. What is the answer you're getting? Please let me know the answer you're getting. This is a very simple problem, and I don't think you will have difficulty in solving these questions. Okay, but yeah, not recommended to expand in this particular form and then solve it. You can always solve it by your own way as well. Like you can write it tan x by tan x into tan x by x. Okay, that is totally fine. Okay, you can go with doing that as well, right? Or since it is a 0 by 0 form, so I would also suggest you applying the L'Hopital rule. Okay, is this part clear to all of you? Is this part clear? Please let me know if this part is clear or not. All right, so I'm waiting for your live chats, so please let me know if you still have any questions. And if you're someone who is watching the session after the live class is over, you can always put your questions in the comment section after the class is over. Okay, so please put your questions in the comments. If you have any questions, I will be very happy to answer your wonderful doubts. Okay, is that clear for all of you? Right, great. Let's move to the next problem. Okay, so the next question we have with us is basically another very simple problem, and it talks about that if t is greater than -1, for t greater than -1, let's say alpha t and beta t are the roots of the equation, are roots of the equation, and we have a kind of a arbitrary equation t plus 2 whole to the power 1 upon 7 minus 1, and then x square plus, then we have t plus 2 whole to the power 1 upon 6 minus 1 multiplied with x plus t plus 2 whole to the power 1 upon 21, then minus 7, and that is equals to 0. And it says that alpha of t and beta of t are the two roots. Okay, so it's very simple. So what we can do is that, so, and it is said that limit as t tending towards minus 1 right hand side, so right hand limit at minus 1 of alpha t and plus beta t. So if I club both of them, because the limit is tending towards the same thing, so it is nothing but a plus b, so as mentioned in the problem, right? Then and we know that alpha plus beta is nothing but the sum of the roots. So sum of the roots is basically, we can write it as, so t tending towards minus 1 positive, that means the right hand limit of minus 1. So sum of the limit is basically minus of b upon a. So if I talk about a general quadratic equation like ax plus b, ax square plus bx plus c is equal to 0. So in this case, if I roots is alpha and beta, the alpha plus beta is basically equal to minus b upon a. So if I do that, I will get the result as minus of t plus 2 whole to the power 1 by 6 minus 1 divided by t plus 2 whole to the power 1 by 7 minus of 1, right? So now in this case, and this is basically given as is equals to a plus b, right? We have to basically find the a plus b value only. So what if I can see the t plus 2 is common? So what if I assume some y is equal to t plus 2? In this case, my limit will become right hand limit at y is equal to plus 1. Okay, and this is going to be y to the power 1 by 6 minus 1 divided by y to the power minus 1 by 7 minus 1, and that can be founded as, so this is basically given as a plus b. So if you just found this limit, we know how to evaluate exponential form. So if you have exponential limit like x to the power n minus a to the power n divided by x minus a, for limit x tending towards a, it is basically nothing but n into a to the power n minus 1, right? So if you recall this result and if you apply over here, this result is going to come out as 7 upon 6, right? So therefore the result that you need to find it out, that is 72 times of a plus b whole square, it is going to come out as 72 times of 49 upon 36, which is nothing but 98. So, okay, which is, this is 2 times, so 2 times of 49, which is 98. So the numeric value of this particular problem over here is going to be equals to 98. I hope this solution is clear to all of you, right? Please let me know if the solution is clear or not. Soumya Ranjan, hi. Hi Soumya Ranjan. How are you doing, Soumya Ranjan? Right? Is this part clear to all of you? Please let me know if this part is clear or not. Okay, so is this part clear to all of you? It's a pretty simple question, okay, and you need to just know the basics of these roots, okay, and equations, okay. So this is a simple quadratic equation was there, and you definitely know it. The sum of the root is basically equals to the minus b upon a, and the product of the root is basically c upon a, right? So if you recall those results, this question is really an easy question, okay. So pretty easy questions though, okay, but yeah, the idea is very important, okay, and you need to know how you should go about evaluating the limits, okay, right? So if this part is clear to all of you, please let me know. We can move with the next problem, okay. That's great, amazing. So let's move to the next problem, right? And next problem is really an interesting problem where you don't have to actually find the limit. You have to basically find the number of points where the function is discontinuous, okay. So basically you need to count for the points of discontinuity, right? So if you look at the function that is given over here, you will see that we have a greatest integer function, right? Right. So greatest integer function are discontinuous, especially at the integers. Okay. So discontinuous at the integer location. Okay. So they are generally discontinuous at the integer location. Okay. So generally you will find out that these particular types of the greatest integer function are generally discontinuous at the integer locations. Okay. So if we look at the function over here, we have with us is basically f of x is basically given as x square by 2 greatest integer of it minus square root of x and then greatest integer of it. Okay. For x belongs from 0 to 4. For x going from 0 to 4. Okay, so if we have this, so if we look at the first term, that is my x square by 2 term, so this particular thing can achieve the integral values 1, 2, 3, 4, and at max to max it will attain 8, right? So if I have the x square by 2 is equals to 1, which means x square is equal to 2. So I will have x equals to root 2, I will have 2, I will have root 6, I will have 2, sorry, 2 root 2, right? I will have root 10, I will have 2 root 3, I will have root 14, and I will have 4, right? I will have these all possible x where this particular function or this particular thing, that is gradient of x square by 2, is discontinuous. Similarly, if I look at the second term, x square, square root of x and gradient of it, you will be knowing that at x equals to 1 and at x equals to 2, so they occur. So the values where gradation of a root x changes straightforward are generally at x equals to. So if you look over here at x equals to 1, yes, and x equals to 2 also, it will definitely change its nature, right? So I mean nature means values or the limit. Okay, so that is means it is discontinuous. Okay, so if I evaluate the f of x at all these potential points, we will find out. So all these potential points is like 1 root 2, 2 root 6, 2 root 2, 2, and then we have root 10, we have 2 root 3. Okay, so please, yeah, then we have root 14, then 4. Okay, if all this location, you will see that these are basically discontinuous points. Okay, so if you count this up, there are going to be 8 points where this particular function is discontinuous. So therefore in the interval from 0 to 4, the particular function is discontinuous at 8 locations. Okay, it's a very simple problem, straightforward. Okay, so if you know the concept behind the greatest integer function and you know that these particular functions are not defined, or like it's not defined, it's like discontinuous, or we have a jump in discontinuity. Okay, jump discontinuity at integral points. Okay, so if you just able to find out the integral points, then you are very easy to solve these questions. Okay, so I hope this question is clear to all of you. I hope this question is clear to all of you, right? Great. So with this question, I would like to stop our lecture over here because I don't want to overdo things again and again. Okay, but in the next classes, we are also going to have with the part 3, and in part 3, we are definitely going to discuss some more questions on differentiability, and then we're going to also talk about the topic of functional equations, okay, which is a very important topic, and sometimes students really have difficulty in order to cope up with the questions of functional equation. So I'll be discussing about the functional equation. Okay, so if you're into this particular channel, please don't forget to hit the subscribe button and click on the bell icon to never miss out any upcoming notification about the classes that is going on in this particular platform. Okay, so in this particular platform, we are having classes each and every day, and we are trying to help you out with your upcoming JEE mains and advanced preparations. Okay, so today's class was bit about the discontinuity and discontinuity part, what we discussed in today, and then in the next upcoming classes, we will also discuss about differentiability and then solve some lot of questions, and then we're going to have a general class where we are solving lots and lots of previous year questions. Okay, especially from JEE mains, JEE advanced, and different sources as well. Okay, so stay tuned for that. It will be very fun. The prep monk. Sir, I have a confusion. Please tell me your confusion, prep monk. Please tell me your confusion, prep monk. Okay, and prep monk, if you want to get more personalized doubt clearance, you can always contact on this number. Okay, please tell me your doubts. Yes, prep monk, please tell me your doubt. It's in general for everyone. Okay, in case any one of you have any questions regarding any topic, or you want to get online classes from me one to one, you can definitely contact us on this particular number. Okay, so please make sure of these free resources as well as with these opportunities where you're getting so low cost education, right? And this is just for one to one education. Okay, you can understand this is so cheap, right? And I would suggest please go for it, because in these sessions we will have personalized doubt clearance, we'll have personalized classes, we will have personalized content as well, and we're also going to send you a lot of mock tests, lot of question practice and DPs as well. Okay, and also I'm going to monitor your progress time to time. Okay, every week we're also going to have some weekly test, and at the end of the month we are also going to have a long monthly test as well. Okay, so that is the best part of these online batches. Okay, to know more about these online batches, you can always contact on this number. Okay, so I see you don't have any doubts, Pep Mom. So let us end our session over here with this particular note, and please stay tuned for the upcoming sessions. We are also going to have part 3 in the coming days, and after that we are also going to solve lots and lots of JEE mains and advanced previous year questions. Okay, so stay tuned for that. If you are currently in, hi Jitendra Kumar, thank you, welcome Jitendra Kumar. Okay, that's great. So with this I take a leave.